Hello everyone. In this session of CCNA series, I will show you how to configure floating static routes. Let's take a scenario where I have a branch office, where I have a user that wants to communicate with a server in the HQ office and wants to share the data between them. For this communication, we have two paths available. One path on which I have 10G links with higher bandwidth, which is running OSPF, which has an administrative distance of 110, and there is a slower link with 1G between R1 and R4 on which I am running a static route. So by default, the traffic will pass through the lower bandwidth link, that is 1G link between R1 and R4. So we have to make sure the traffic is passing through the higher bandwidth link, that is 10G link between R1, R2 and R4, and use the static route as a floating static route in case if the link between R1 and R2 or R2 and R4 goes down, the traffic should shift to R1 and R4. Let's go ahead and see how the traffic is passing on PC2. If I do a trace route, it will show which hops it is using by default. As you can see, it is passing through the lower bandwidth link, that is between R1 and R4, which is using the subnet 192.168.5.0. This is the hop where you can see the traffic is passing between the 1G link. Let's go and log in into the router and see how the traffic is, what is the status of the routing table. If you see show IP route, I have a route to the subnet of the HQ via 5.2 through a static route. So first thing what we need to do is we need to make sure this static route is not preferred, and we can do this by using floating static route. For that, I need to type in the command IP route 192.168, which is our destination subnet, with mask, and the next hop, that is 192.168.5.2 with administrative distance increased. By default, the administrative distance is 1, as you can see here. So we need to make it 250. Similarly, I have to configure this on another router on which our server is connected in HQ. (192.168). This is the reverse route. And the next hop will be 168.5.1 with add AD 250. Now I have to clear the IP routing table in packet tracer so that the new route reflects. Here you can see now the subnet of the branch office is learned via OSPF. Similarly, on router R1 as well, we need to clear IP route so that the updated routes are available. Now you can see the subnet 192.168.4.0 on the branch office router is learned via OSPF. Earlier it was learned via static because the AD was 1. Here you can see the AD is 110. Let's go ahead and do a trace route now and see how the packet is going. It goes to R1, R2, R3 and then R4. As you can see, it goes to R1, R2, R4 and then PC3. This is the IP of the R1, this is the IP of the R2, and then this is the IP of the R4 interface 3.3. So now the traffic is taking the proper path on which we wanted it to be passing through 10 gig links. Now let's go ahead and fail the link between an R1 and R2 to see if the traffic is going to the 1G link. That is our main purpose. So I will hop on to the R1 and shut the link. This is the link which we are going to shut, 0/0/0/0/0/1. So if we shut this link, the OSPF neighborship will be down and the IP routing table should point the destination using static route. You can see our floating static route is active now with AD250. Now let's go ahead and hop onto the PC and see if the path, now you can see it's taking the static route path which is through 1G link. That's it for this session. I hope this was informative for you. Thank you for watching. Please do like. If you have any comments, please do let me know.